Most people think the hardest part of gardening is soil or pests or choosing the right plants. After years in the dirt, after watching trends rise and crash, I can tell you that water is the real bottleneck. Not just how much you use, but how often you have to think about it. Because the moment your gardening depends on daily attention, it stops being resilient and starts owning your time. And that's where most modern systems quietly fail. Here's the part that still surprises people. Long before timers, drip lines, pressure regulators, or smart irrigation apps, ancient growers solved this problem in a way that's still brutally effective today. No electricity. No moving parts. No programming. Just physics, soil biology, and patience. Some of these systems are over 4,000 years old, and when you actually test them side by side with modern irrigation, they don't just hold up, they often outperform them in the one metric that matters most to backyard gardeners. Consistency. I'm not talking theory here. I've buried these systems in bad soil, in good soil, in raised beds and native ground. I've let them run through heat waves, travel weeks, and forgetful stretches. I've compared them to drip lines, hoses on timers, and hand watering. And what you learn fast is this. Plants don't want bursts of water. They want access to moisture on demand, at the root zone, without stress. That's the idea ancient growers understood instinctively, even if they didn't use modern language to explain it. Before we get into specific systems, there's something important to clear up. This is not a ditch modern irrigation video. Modern systems absolutely have their place. But most backyard gardeners don't need complexity. They need reliability. They need forgiveness. And they need something that still works when a battery dies, a line clogs, or life gets busy. The hybrid approach combining ancient passive watering with selective modern tools is where things get interesting. That's where you stop fighting your garden and start designing it to work with you. Let's start with the backbone of this entire concept. At the center of nearly every ancient low-water system is one principle: slow, constant, underground moisture delivery. Ancient farmers didn't dump water on the surface and hope it soaked down. They stored water below ground and let plants pull what they needed through capillary action. This does two things modern watering often fails at. First, it eliminates evaporation loss. Second, it trains roots to grow deep and resilient instead of shallow and fragile. This is why surface watering creates dependency. Plants adapt to their environment. If water always comes from above, roots stay near the surface. If water lives deeper, roots chase it. That difference alone determines whether your garden survives a mist week or collapses the moment you forget. One of the oldest and simplest expressions of this idea is olla irrigation, and yes, it really is that old. Archaeological evidence places buried clay pot irrigation systems in ancient China, North Africa, and parts of the Middle East more than 4,000 years ago. And the reason they spread across cultures is simple. They work anywhere soil exists. An olla is nothing more than an unglazed clay vessel buried in the soil, filled with water and sealed at the top. The clay is porous. As the surrounding soil dries, it pulls moisture through the walls of the pot. When the soil is already moist, the flow nearly stops. That self-regulating behavior is the magic. No timers, no guesswork. The plant decides when it drinks. When I first tested this system years ago, I was skeptical. It sounded too primitive to compete with modern drip irrigation. But once you install it properly, and that part matters more than most people admit, the results are hard to argue with. Beds watered by olla irrigation stay evenly moist without ever becoming waterlogged. Fungal issues drop. Weeds decrease because the surface stays drier. And water use drops dramatically, especially in hot climates. Now, here's where the hype often goes wrong. People treat ollas like a miracle drop-in solution. They bury one pot, plant too far away, and then claim it doesn't work. The reality is that an olla has a defined moisture radius, usually between 12 and 24 inches, depending on soil type. Clay content, organic matter, and compaction all affect how far that moisture travels. Ancient growers didn't guess this, they learned it through generations of observation. This is one of those areas where modern knowledge actually improves an ancient system. Mapping root zones, understanding soil texture, and spacing ollas correctly turns a historical trick into a high-performance watering strategy. If you've ever tried drip irrigation, you already know its biggest weakness. Emitters clog, pressure varies, tubing shifts. One tiny failure point can quietly starve a plant while everything else looks fine. Drip systems are efficient on paper, but they demand vigilance. Olla irrigation, by contrast, fails loudly. If the pot is empty, if it's cracked, you see it. There's no hidden failure mode. That said, ollas aren't perfect. They don't scale well for large fields. They require initial digging. And cheap modern versions are often poorly fired, leading to inconsistent seepage. Ancient ollas were handmade, low-fired, and porous by design. Many modern mass-produced versions try to be decorative first and functional second. That's something to watch closely. This is where the hybrid mindset becomes important. Pairing olla irrigation with modern raised bed design, mulch layers, and occasional surface watering during extreme heat creates a system that's both ancient and adaptive. Another ancient approach that deserves serious attention is the wicking bed. While the term is modern, the concept is not. Variations of sub-irrigated planters existed in ancient Persia and later Roman gardens, where water was stored below the root zone and wicked upward through soil layers. A wicking bed is essentially a sealed or semi-sealed container with a water reservoir at the bottom and soil above it. Through capillary action, water moves upward as plants need it. When built correctly, these systems can go weeks without refilling, even in warm climates. I've tested wicking beds in containers, raised beds, and improvised setups using stock tanks and recycled materials. The performance depends almost entirely on construction quality. Get the layers wrong, and you'll drown roots or starve them. Get it right, and you'll wonder why surface watering was ever the default. What ancient builders understood and many modern DIY guides skip is the importance of oxygen. Roots need air as much as water. Ancient sub-irrigation systems often incorporated gravel layers, air gaps, or porous materials to prevent stagnation. Modern wicking beds fail when people oversimplify them into water at the bottom, soil on top. The hybrid advantage here is using modern materials, geotextile fabric, perforated piping, overflow drains while respecting ancient spacing and airflow principles. Done correctly, a wicking bed becomes one of the most forgiving watering systems a backyard gardener can build. Now, let us talk about something most people don't associate with backyard gardening at all: qanat-style subsurface water movement. True qanats were massive underground tunnel systems designed to move water across long distances using gravity alone. Obviously, you're not digging a mountain tunnel in your yard. But the principle behind qanats' cool, shaded, underground water movement applies at small scales. In gardens, this shows up as buried channels, perforated pipes, or stone-filled trenches that slowly distribute moisture below the surface. I've seen versions of this used in Mediterranean-style gardens where surface watering is nearly non-existent. The soil stays cool. Roots stay deep. Plants survive heat that would destroy surface-irrigated beds. The mistake people make is trying to replicate the structure instead of the function. You don't need ancient architecture. You need controlled subsurface moisture that moves slowly and predictably. A shallow gravel trench connected to a reservoir can outperform an above-ground sprinkler if designed with intention. At this point, it's worth asking yourself something, and I'll ask you directly because this matters. Have you ever had a garden that thrived when you left it alone, but struggled the moment you started optimizing it? That's not accidental. Plants evolved for stability, not intervention. Ancient systems were designed around that truth. This is also where modern gardening culture quietly misleads people. We're taught that better tools mean better outcomes, more control, more precision, more data. But water is not something plants want delivered on a schedule. They want access. That distinction changes everything. If you've ever overwatered while trying to help, you already understand this at a gut level. One thing I'll say clearly because it needs to be said. Ancient watering systems are not romantic nostalgia. They're practical engineering solutions refined by failure. Civilizations that mismanaged water didn't survive long. The ones that did left behind systems that worked under pressure, drought, and inconsistency. That doesn't mean modern tools are useless. Soil moisture meters, for example, are incredibly helpful when dialing in hybrid systems. But the meter should confirm what the system is doing, not replace it. If you're curious about materials, diagrams, or example builds for any of the systems I'm talking about, I've linked reference resources in the description. No pressure, no hype, just things that genuinely help me refine these setups over time. As we move forward in this series, we'll break down exactly how to combine olla irrigation, wicking beds, and subsurface distribution into a single backyard system that can survive neglect without sacrificing yield. We'll also talk honestly about where modern drip and sprinkler systems still make sense and where they quietly waste your time and water. Before we wrap this first part, Let me leave you with one expert-level insight that took me years to fully accept. The best watering system is not the one that reacts fastest. It's the one that changes the slowest. Stability beats responsiveness almost every time in the garden. By the time most people decide to upgrade their watering system, they're already reacting to a problem. Plants are wilting, water bills are climbing, summer travel is coming up. And the usual advice they hear is to add more control timers, emitters, zones, apps. What almost no one tells them is that the foundation matters more than the hardware. If the underlying system is unstable, no amount of automation fixes it. It just masks the symptoms. This is where ancient systems quietly outperform modern ones. They don't rely on reaction, they rely on buffering. They store water, slow it down, and let plants draw from it when needed. In this part, we're going to move from concepts to construction. What actually works when you're standing in your yard with a shovel, a limited budget, and soil that's rarely ideal? Let us start with the most important decision you'll make before building anything, where the water lives. Ancient systems always answered this question first. Is the water stored in a vessel, a reservoir, or the soil itself? Modern gardening often skips this step and goes straight to delivery. That's backwards. In a backyard hybrid system, you're usually working with all three. Olla irrigation stores water in vessels. Wicking beds store it in a contained reservoir. Subsurface trenches store it directly in the soil matrix. The mistake is treating these as separate ideas instead of layers of the same strategy. When I design a bed now, I think vertically, not horizontally. What's happening at the surface? What's happening 6 inches down? What's happening at root depth? Ancient growers didn't have cross-section diagrams, but they absolutely understood soil profiles through observation. We can do better because we have both experience and measurement. Let's talk about olla placement because this is where most people fail early and give up too soon. An olla doesn't water plants, it conditions soil. The roots come to it. That means spacing matters more than pot size. In loamy soil with good organic matter, a medium olla can serve plants within roughly a 16 to 18-inch radius. In sandy soil, that radius shrinks. In heavy clay, it expands, but slower. Here's the insider rule most guides don to mention. It is better to use more small ollas than fewer large ones. Large pots create uneven moisture gradients. Smaller vessels distribute water more predictably and refill faster. Ancient systems favored redundancy for a reason. One cracked pot didn't doom the crop. Depth matters just as much. The shoulder of the olla should sit slightly below the soil surface, never exposed. Exposed clay accelerates evaporation and encourages algae growth inside the pot. I've tested shallow and deep installations side by side. Deeper always wins for consistency, especially in hot climates. Now let's layer this with wicking principles. A common mistake is treating wicking beds as all-or-nothing systems. Either you build a fully sealed raised bed or you don't bother. Ancient growers didn't think that way. They blended passive capillary action wherever it made sense. In practical terms, this means you can create partial wicking zones inside standard beds. A gravel-filled trench lined with fabric beneath your planting area acts as a micro-reservoir. It doesn't need to hold weeks of water, it just needs to buffer daily swings. This is especially effective under heavy feeders like tomatoes, squash, and peppers. The key is oxygen. Every time someone tells me their wicking bed failed, the root cause is almost always anaerobic conditions. Ancient systems avoided this by default because they used coarse materials and imperfect seals. Modern builders over-engineer and accidentally suffocate roots. If you're building a dedicated wicking bed, include an overflow outlet, always. Ancient systems assumed excess water would move somewhere. Stagnation was never part of the design. An overflow isn't a modern upgrade, it's a return to common sense. Now let's talk about subsurface distribution, the least understood and most powerful part of a hybrid system. You don't need to recreate a qanat to apply the principle. You just need water to move slowly, underground, and laterally. One of the most effective setups I've used is a shallow trench, about 8 to 10 inches deep, filled with coarse sand or fine gravel, capped with soil. This trench connects to either a rain barrel, a buried reservoir, or even excess runoff from a roofline. When it rains or when you manually fill the system, water spreads horizontally instead of pooling vertically. Plants planted above or beside these trenches behave differently. Roots grow deeper. Stress tolerance increases. And surface soil stays drier, which reduces weeds. Ancient systems didn't fight weeds with chemicals. They starved them of surface moisture. Here's where modern tools earn their place. A simple soil moisture probe can tell you whether your subsurface system is actually doing its job. Use it sparingly. You're not chasing perfect numbers, you're confirming trends. Is the soil drying evenly? Is moisture lingering too long? Ancient growers used plant behavior as their probe. Wilting patterns, leaf curl, growth rate, we can combine both. At this point, it is worth addressing a question I hear constantly. Why not just use drip irrigation underground? On paper, subsurface drip looks like the perfect hybrid. In practice, it introduces fragility. Roots invade emitters. Lines clog invisibly. Failures happen where you can't see them. Ancient systems favored visibility and simplicity. When something broke, it was obvious. That doesn't mean drip is useless. In a hybrid system, drip works best as a supplement, not a backbone. Use it during establishment. Use it during extreme heat. But don't rely on it for baseline survival. That role belongs to passive storage. Let's pause here and make this interactive, because I'm curious. Have you ever built a system that worked great for one season and then mysteriously failed the next? Drop a comment if that's happened to you. 9 times out of 10, the issue wasn't the plants, it was how water moved or stopped moving underground. Another overlooked factor is mulch, and ancient systems treated mulch as structural, not decorative. Organic mulch isn't just about moisture retention. It's about temperature buffering and microbial stability. A hybrid system without mulch is like a reservoir without a lid. I've tested bare soil versus heavily mulched beds over identical subsurface setups. The mulched beds consistently used less water and recovered faster from stress. Ancient growers used straw, leaves, reeds, whatever they had. The material matters less than the coverage. Modern bark chips work. Shredded leaves work. Consistency beats aesthetics. Now let's talk honestly about labor, because no system is truly low maintenance. Ancient systems reduced frequency, not effort. You still have to refill ollas. You still have to check reservoirs. The difference is timing. Instead of daily attention, you move to weekly or even bi-weekly rhythms. This shift matters psychologically. Gardening becomes sustainable when it fits into life, not when life has to orbit it. That's one of the quiet lessons ancient systems teach. They were designed for farmers managing multiple responsibilities, not hobbyists with infinite time. If you're wondering about materials, clay pots, fabrics, gravel sizes, I've put reference links in the description to resources that help me avoid expensive mistakes early on. Not endorsements, just things that held up under real use. Before we end part 2, here's a balanced truth that doesn't get enough airtime. Ancient systems are slower to respond. If you drastically underwater, recovery takes time. Modern systems can correct faster, but they also create bigger swings. Stability versus responsiveness is a trade-off. In most backyard gardens, stability wins. If you really want to understand whether a watering system works, you don't test it on a perfect week. You test it when everything goes wrong, heat spikes. Wind dries the soil faster than expected. You miss a refill. You leave town. Ancient systems weren't designed for ideal conditions. They were designed for survival under uncertainty. That's the standard we're going to use here. Over the years, I've intentionally stress-tested hybrid setups because real gardens don't operate in controlled environments. I've left beds unattended during summer travel. I've run them through unexpected heat waves. I've compared plant response after deliberate underwatering. And what you learn fast is that failure looks very different in passive systems than it does in modern reactive ones. Let's start with heat, because this is where most gardens collapse first. In surface-watered systems, heat accelerates evaporation. The soil dries from the top down, roots stay shallow, and stress compounds quickly. In contrast, hybrid systems built around olla irrigation, wicking zones, and subsurface storage respond more slowly. Moisture remains available below the surface, even when the top layer looks dry. Plants may show mild midday wilt, but they recover by evening without intervention. That recovery pattern matters. Temporary wilt isn't failure, it's a pressure release valve. Ancient growers accepted short-term stress as normal. Modern gardeners often panic and overcorrect, which causes root damage and fungal problems. In hybrid systems, learning when not to intervene is just as important as knowing when to step in. One of the most revealing stress tests is neglect. Not catastrophic neglect, just the kind that happens when life gets busy. In my tests, Beds relying on passive underground moisture consistently outperform surface-irrigated beds after 5 to 7 days without attention. Not because they had more water, but because the water they had was protected from loss. This is where olla irrigation shines. Even when an olla runs dry, the surrounding soil doesn't crash immediately. Moisture gradients flatten slowly, giving plants time to adapt. Compare that to drip irrigation. When a drip line fails, stress is immediate and localized. One plant suffers while its neighbor thrives, and you don't see the problem until damage is already done. Now let's talk about the failure modes people rarely discuss honestly. Ancient systems don't fail dramatically, they fail quietly. A pot cracks, a reservoir silts up, a trench compacts over time. These failures reduce efficiency, not function. Plants may grow slower, not die outright. That's an important distinction. Modern systems, by contrast, tend to fail cleanly and suddenly. A timer dies, a line disconnects, pressure drops. The system works perfectly until it doesn't. From a resilience standpoint, that's a weakness. Ancient designs favored graceful degradation. When something went wrong, the system still functioned, just not optimally. This difference shows up clearly during long absences. I've left hybrid systems alone for 2 weeks in summer. Were the plants at peak productivity when I returned? No, but they were alive, rooted, and recoverable. Surface-watered systems in the same conditions didn't get that chance. At this point, a lot of people ask the same question, and it's a fair one. Okay, but what about yield? This is where myths thrive, so let's be precise. Ancient-style watering systems do not automatically produce higher yields. They produce more consistent yields under variable conditions. In ideal, heavily managed environments, modern irrigation can push plants harder. More water, more nutrients, faster growth. But that comes at a cost: fragility. Miss the schedule, and the whole system unravels. In side-by-side comparisons, I've seen modern drip-fed beds outperform hybrid systems during short, controlled growing windows. But over an entire season, especially one with weather swings, the hybrid systems often catch up or surpass them in total usable harvest. Fewer losses, less stress-related disease, more uniform plant development. Ancient growers optimized for reliability, not maximum output. That mindset matters in backyard gardening, where conditions are rarely perfect. If your goal is consistent food with minimal babysitting, ancient principles win more often than not. Another misconception worth clearing up is nutrient delivery. People assume passive systems starve plants because there's no constant feed. In reality, stable moisture supports microbial life, which improves nutrient cycling. Plants fed slowly often develop stronger root systems and more balanced growth. That doesn't mean you ignore fertility. It means you time it differently. In hybrid systems, nutrients are best applied in ways that don't depend on frequent flushing. Compost, slow-release amendments, and diluted liquid feeds work better than aggressive fertigation. Ancient systems paired water stability with soil building, not chemical precision. Let's pause again and bring you into this conversation. Have you ever chased bigger yields and ended up with weaker plants? Or had a season where everything looked great until one missed watering ruined it? If so, you've already experienced the trade-off we're talking about. One of the hardest habits to unlearn is surface monitoring. Gardeners judge success by what they can see. Wet soil looks healthy. Dry soil looks neglected. Ancient systems flip that logic. A dry surface with moist subsoil is ideal. It discourages weeds, protects microbes, and encourages deep roots. This is where people get nervous and interfere too early. I've done it myself. The fix is trust, backed by observation. Use your hands. Dig small test holes. Learn what healthy moisture feels like below the surface. Ancient growers did this instinctively. We have to relearn it. Now, let's talk about climate extremes, because this is where hybrid systems earn their reputation. In prolonged heat, no passive system is invincible. There's a point where demand exceeds stored supply. The difference is how the system signals that stress. Hybrid systems give warnings. Growth slows. Leaves angle differently. Flower drop increases. These are cues, not emergencies. Modern systems often hide stress until a threshold is crossed, then collapse quickly. During drought conditions, the ability to prioritize becomes critical. Hybrid systems allow selective intervention. You can top off ollas for key plants. You can refill reservoirs strategically. You're not locked into an all-or-nothing watering cycle. That flexibility is ancient wisdom applied to modern constraints. Before we wrap this part, I want to address a subtle but important truth. Ancient systems change how you think about control. They force patience. They reward observation. They punish overreaction. That's uncomfortable in a culture used to instant fixes, but it's also why they endure. If you want diagrams, seasonal case studies, or side-by-side comparisons I've referenced here, those are linked in the description. They're there to support your understanding, not sell you a solution. By the time you reach this point, the mechanics of ancient watering systems aren't the mystery anymore. The real question is integration. How do you take olla irrigation, wicking principles, and subsurface distribution and turn them into a single, coherent backyard system that actually fits your climate, your soil, and your life? This is where most advice falls apart, because it tries to give universal rules for something that has always been local. Ancient growers didn't copy systems blindly. They adapted principles. That's the mindset that makes this work today. Let's start with layout because integration begins on paper, not in the ground. When I design a hybrid system now, I don't start with plants. I start with water movement. Where does water enter the system? Where can it be stored? Where will gravity help me and where will it work against me? These are the same questions ancient engineers asked, just at different scales. In a typical backyard, water comes from rain, hoses, or stored barrels. The mistake is treating these as separate inputs. A hybrid system works best when they feed the same subsurface structures. Roof runoff can top off a buried reservoir. A hose refill can replenish ollas. Excess water can overflow into a trench that spreads moisture laterally instead of letting it escape. This is where subsurface trenches act as the glue. They don't replace ollas or wicking beds. They connect them. Think of them as slow-moving arteries beneath the soil, redistributing surplus and buffering shortages. Even a short trench placed on contour can dramatically change how water behaves across a bed. Now let's talk about climate, because this is where adaptation matters most. In hot, arid climates, evaporation is your enemy. Ancient systems in these regions emphasized depth and shade. Ollas were buried deeper. Soil surfaces were heavily mulched. Plant spacing allowed airflow without exposing soil. In these conditions, hybrid systems should favor fewer surface interventions and larger underground buffers. In humid climates, the challenge flips. Excess moisture and poor drainage cause more damage than drought. Ancient systems here prioritized airflow and runoff. Wicking beds need generous overflow. Subsurface reservoirs must drain freely. Ollas should be spaced to avoid saturation. The principle stays the same, but the execution changes. Temperate climates sit in between, which is why hybrid systems shine there. You can lean on passive watering most of the season and supplement selectively during extremes. The goal isn't to eliminate watering, it's to decouple plant survival from constant attention. One thing I want to say clearly because it's often misunderstood. A garden that survives without you is not a neglected garden, it's a buffered garden. Ancient systems weren't lazy solutions. They were insurance policies against unpredictability. The difference is intention. This brings us to plant selection, an area where ancient wisdom and modern breeding sometimes clash. Many modern varieties are optimized for high-input systems. They perform best with frequent watering and feeding. In hybrid systems, they'll survive, but they may not shine. Heirloom and regionally adapted varieties often respond better to passive watering. They've retained traits that favor deep rooting and stress tolerance. This doesn't mean you avoid modern plants, it means you're honest about expectations. High-demand crops go near ollas or wicking zones. Lower-demand plants live in the margins. This zoning concept is ancient, even if we rarely name it. Not every plant needs equal attention. Designing with that in mind reduces effort without sacrificing productivity. Let's talk about maintenance because no system is set and forget forever. Ancient systems lasted because they were simple to maintain. Clay pots could be replaced. Channels could be cleared. Reservoirs could be flushed. A hybrid backyard system should follow the same logic. Once or twice a season, I inspect ollas for cracks. I check reservoirs for sediment. I probe soil in a few places to confirm moisture patterns. That's it. No daily adjustments. No constant monitoring. Just periodic confirmation that the system is behaving as designed. Modern tools can support this without dominating it. A soil moisture meter used a few times a month can catch slow changes before they become problems. Rain gauges help you understand natural inputs. But these tools inform decisions, they don't automate them. This is a good moment for one final engagement check-in. If you were designing your garden today, which part would you trust least: your soil, your watering schedule, or your ability to stay consistent? That answer usually points to where ancient systems offer the biggest benefit. Before we close, I want to address the biggest myth of all, that ancient systems are about going backward. They're not. They're about reducing dependency. Modern irrigation is powerful, but it assumes stability, stable power, stable parts, stable schedules. Ancient systems assume none of that. They assume interruption, variability, and human distraction. That assumption makes them surprisingly modern in a world that's anything but predictable. Here's the final expert takeaway I wish someone had told me years ago. The most resilient gardens aren't the ones with the best technology. They're the ones designed around forgiveness. Forgiveness for missed days, forgiveness for heat waves, forgiveness for human error. Ancient watering systems embody that philosophy. When you blend them with modern materials and knowledge, you don't just save water, you change your relationship with your garden. It stops demanding constant proof of care and starts responding to trust. If you want deeper breakdowns, diagrams, or case studies that go beyond what we could cover here, those resources are linked in the description. They're there to help you adapt these ideas to your own space, not to sell you a template. If this series helped you rethink how water actually works in a garden, consider liking the video and subscribing. And if you're curious about how these principles apply to other parts of growing soil building, plant resilience, even pest pressure, there's another video waiting that builds directly on what we covered here. Remember, it's not about watering less. It's about watering smarter, slower, and with intention. And that's a lesson that's lasted 4,000 years for a reason.